We're back to the Swivl. So we're going to actually have some lessons in here. We've had a lot of time between the tests and the review and all that. We didn't have many actual lessons. So we are going to start our new unit. So in your notebook, you can break that out and write that down. But then also have your problem set open, the one that I just gave you back, because I want to clarify and make sure you understand number 5, like what's going on in number 5, because that ends up being something that's going to be important for us to be able to do. And you're going to watch your calculator out, your graphing calculator. Okay, let's get the problem out of the way. So get your calculator out. I want to demo number 5 because there were a fair number of people that got that one wrong, and I want to make sure that you understand how to go about that one. So let's do number 5. So the question says, which of the following is an equation of the line tangent to the graph of f of x equals at the point where f prime of x equals 1. Now that's different than asking f prime of 1. It's where f prime of x is equal to 1. So this means when the slope is equal to 1. Slope of that line tangent. So this one here has a little asterisk on it. It says the problem requires a calculator to solve one part. So you may use the calculator to do that problem. So let's take a look at it. So the original function was f of x equals x to the 4th plus 2x squared. So we need to find the derivative on this one. So we find the derivative, which is 4x to the 3rd plus 4x. But then this is the key step right here. Okay, this is what not everybody had. So I want you to be aware of this. The problem says, find the point here, find the equation of line tangent at the moment where f prime of x is equal to 1. So what you have to do in this problem is you have to set the derivative equal to 1. See what I did there? I took the derivative and I set it equal to 1. That's not plugging 1 in. It's setting the derivative equal to 1 and then solving. Now, what this does is it forces you to be able to find the x value for when the derivative is 1. That's what this allows you to do. It's like reversing it. So we got to just solve this thing for x. Well, if you subtract 1 from it, set it equal to 0, you get 4x cubed plus 4x minus 1. This is the moment where you're supposed to use your calculator. So it's at this precise moment. So let's go ahead and solve this. So what I'm going to do is I'm going to take this equation and we're going to graph it and find out when it's equal to 0. So I'm going to my y equals here and I'm going to put in the function. And I'm going to put in just the right side here, 4x cubed plus 4x minus 1 into my y1. So 4x to the 3rd plus 4x. Oopsie. There we go. Plus 4x minus 1. Okay? So that's the right side of this equation right here. It's just this one right here. And I want to find out, hey, when is it equal to 0? So I'm going to do zoom 6 to see what this thing looks like. So it looks like it does this curvy thing. It kind of makes sense. It's a cubic. So it's coming here. It's got a positive coefficient of 4. So it's going to go up and then do a thing and then go up. That's what it does for a cubic. So I want to know, when does this function equal 0? Well, at the point where it crosses the x-axis is where it's equal to 0. That's why they call it a 0. That's why when you go to your calculator, you press second calc. On the graphing part, you can go and find a 0. So, but watch what happens here. I press 0, and I got to give it the old left bound, right bound, and then put a guess in between. And it gives me this number, 0.2367329. This is the x value where the function is equal to 0. So we have solved this equation. So stop and think about it. You can solve any equation on your calculator by just graphing it and then finding out where it's equal to 0. Okay? But this is the most important thing. Everybody write this down somewhere. From now on, whenever we write down decimal numbers and numbers that have a decimal, you're going to only write 4 decimal places. No more, no less. 4 decimal places is what you're going to write down. What's that? Yeah, I know. Let me tell you the exact reason. The AP test makes you be accurate to 3 decimal places. We're going to do 4, then we don't have to ever worry about rounding, because they take either rounded or truncated, but it can get confusing. So we're just going to always write 4. Some of you may get in the habit of, I wonder how many so I should put down. So you put down all of them. You know, you're out like 10 decimal places. Okay? Don't do that anymore. From now on, you only have to write 4. But now, do you realize that if we only use 4 going forward, we've now just decreased our accuracy? So you write down 4, but you use all of them. And let me explain how we're going to do that. The last calculation that I did was finding the 0. The calculator has a good short-term memory in that if I press clear, it remembers what that number is. And so if I press X, it's stored in the calculator with all the decimals. Okay? So we are going to actually use that in the problem, because I think after we did this, we had to find the y1 value. We had to find the y value of that. So the original function was x to the 4th. So watch this. It's so cool. I'm going to go x raised to the 4th. And then plus 2x squared. And it gives me the number of the 0.1152 and so on. Because it knows that x is 0.2367 and so on. So it's actually doing 0.2367 to the 4th plus 2 times 0.2367 squared and computing that. That gives us the actual answer for this spot automatically. All right. From now on, though, whenever you write decimals, 4 decimal places, no more, no less. But then carry through all of the decimal places through to the answer, but you only have to write 4 of them. Make sense? Okay. All right, do that from now on anytime you have to do that. We're going to be doing a lot more calculator use in this chapter. Okay, so if you haven't copied down what's on the back board, go ahead and do that. We are moving on. So the brand new unit, the one that we're going to spend all of the rest of the time until the semester ends, first semester ends, is going to be on applications of the derivative. So now this is a good 4.5 week unit. We will have a test at the end of this unit, and then you will also have a semester exam. Okay? So that's how that's going to work. Our number one goal, our first goal, is to be able to sketch a function given its derivative. Okay? So that's what we're going to start off. If you were here on the 2 days before we left for Thanksgiving break, you know we went in the computer lab and we got to play with this a little bit. You played that one thing where you're shooting for your accuracy, where if you're given the function, you can go either way. Given the function, find the derivative, or given the derivative, find the function. But what we're going to practice right now is finding the function given the derivative. And I started off with one that should look familiar. Okay? This is the graph of f prime. Okay? So we are going to do the ones where you start off with the derivative and we're going to draw the function. Okay? So we do these in intervals. So we're going to always start on the left and work our way to the right. Okay? So as we do this, let's take a look. At x equals -3, this has a slope of -1. Okay? What does that mean in terms of the function? It means that it's going down, right? And it's got a slope of -1. Okay? But look at this. For every one of these x values, the slope is -1. You see that? So that means I know if I'm graphing this, I can graph something that looks like this right here. That graph has to look like this because for every one of those, that's a slope of -1. Okay. Likewise, the derivative is +1 for all of these values. That means that if I would draw the function, I would draw a slope of +1 for each of those values. So that means if I draw the function based upon the derivative, f prime, this would be a possible graph. Okay? So let's graph it and see what it looks like. So here it is. Uh-oh, we got it wrong. It was supposed to be down here. We did it up here. Look at a keyword right here. Right there. If this function, does this function and this function, do they both have the same derivative? Yes. Functions can differ by a constant being added on, and their derivatives will be exactly the same. So any sort of vertical shift with a plus or a minus of a number is okay when we're sketching a function because the derivative of it of the constant is 0. So both of these are legitimate functions that we draw. Okay. All right, now I'm gonna put down a couple of other ones here, and we're gonna work our way backwards. Okay. This is another one where this is the graph of, the green one is the graph of f prime. Okay. So what does the graph of f look like? What does the graph of f look like? So let's see if some of this is making sense what I'm saying here. What's true from here to here? The slope is positive. Okay? Because this is the derivative, the slope is positive, so tell me about what's going on with the function. F, we say, is increasing. The function is increasing on the interval from here to here. And the reason why it's increasing is because f prime is positive. Look at over here. This interval from here to here, what's happening to f? Same thing. F is increasing because f prime is positive. So the function, the red one that I'm going to draw, is going up here and here. Because f prime is positive. The slope is positive for all of the functions' slopes on both of those two intervals. Then what's happening between here and here? F is decreasing on the interval from here to here because f prime is negative. Remember, this is the graph of f prime. It's the derivative. Okay. Now, let me show you what the function looks like. Now, this is important that you really take a close look at this, because we spend a lot of time analyzing the graphs. Look at the red graph, okay, which is really the one that's in purple here. This is the graph of f. So f is in purple. We said that the function is increasing from here to here. Did it do that? Yes. It increased as we go. Remember, we always go from left to right. So it's increasing as we go from this point to this point. That's what the purple one did, and that's our derivative told us so. Look at the other place where it was increasing, from here to here. The function went up from here to here. Because we knew that because the derivatives were all positive. The slopes were all positive. And finally, look at this. The x interval from here to here, if you draw the purple graph said it was decreasing from here to here. And every one of these derivatives was negative. Does that make sense? Okay. Now, remember we said wherever the derivatives are 0, that's where you're going to have a slope of 0. And that's what we have here. A slope of 0 that matches up with this one, and a slope of 0 which matches up with this one. Make sense? do another one. For every one of these, I did a piecewise function so you could see it. Okay, get together with somebody, compare notes. If this is the graph of the derivative, what would the function look like? The most important things are, where is the function increasing and why? And where is the function decreasing and why? Okay, get together with somebody and do this sketch. I'll try to make this even bigger. You have to compare with at least one person, and then I'd be explaining why to each other. Okay, compare answers. I'm only looking at the intervals themselves. And are you increasing and decreasing in the right places for the right reasons? And I'm going to simplify this. Even though it's not right smack dab on it, I'm going to make this right at -3 and write this at +3. It's, or pardon me, -3 and +3. Here we go. Just so you have something to work off of. And these are both at -5 and +5 then. All right, I'm going to write out the proper way to do this. And so you can see an example of how we can justify it. All right, let's do this. Here's the correct way to say this. F, the function, is increasing on, and the intervals that it's increasing on are from -5 to -3 and 3 to 5 because on the AP test, if you forget the reason why the justification, you don't get the point. So the function f is increasing on the intervals from -5 to -3 and from 3 to 5 because f prime is positive. You look at the yellow graph, both of these intervals, the derivative is positive. That means the function is increasing. Likewise, the function f is decreasing on the interval from -3 to +3. Okay. The function is decreasing on that interval because why? Because f prime is negative. Okay? So we can say f prime is negative, or the best mathematical way to say it is just f prime is less than 0. Okay? Say it again.
What happens when they set the 0?
Right at 0, the slope is 0.
But when you
We don't have to write that out. Okay, so let's see how you did. Did you have a function that looked kind of like this? Yes.
Does it have to reposition?
No. No. You can if you want to, or you can just use that. You can just say and. Now, I'm going to guess most of you had something that kind of looked like a sine wave, right? So I'm going to tell you a secret. It's really an amazing secret. Okay? The question of how much does it increase, okay, or how much it decreases is actually hidden inside the derivative. Okay? But you have to know where to look for it. Watch this. Remember we said from -3 to +3, this is where the function increases? It goes up this much, right? In other words, it went from here all the way up to here. That's how much it increased by. See what I'm looking at here? From here, the function went from here to here. Okay? That number, the amount that it increased by, going from here to here, is hidden within this green graph. Here's where it's hidden. If you draw a line straight down, and you draw the graph, and you find now the area bounded by the curve, the derivative, and the x-axis. The area of this region is how much the function goes up by.
You're going to make us calculate that now, aren't you?
You don't know where it starts unless you're given an initial value of some kind. And we're going to do that in the second semester. So wait a second. If the area above the x-axis bounded by the curve is the amount that the function increases by, and you say, well, how much does the function decrease by from here to here? Now that's a lot, right? Because it went from all the way up here, all the way down to here, right? So I draw my arrows this way. The function started off up here, I should say, and it went all the way from here down to here. How much is that? Well, guess what? The amount that it decreased is actually equal to the area of the curve bounded by the function, which is the derivative, and the x-axis. This area answer is a number. It's some number. It represents the change in the function over that same interval. That's how you can know that you're not drawing a sine wave, because it goes up a little, then it goes down a lot, then it's going to go up a little again, because the area here, that area represents how much the function goes up. Does that make sense? Okay, that's an introduction of something that we're going to be doing a lot later. All right, let's do another one. Here's another function. Okay, notice the interval is from -6 to 6. -6 to 6. And this is the graph of the derivative. Tell me what the graph of the function looks like. I gotta get some spray paint. Yeah.
That's in his words. I know, but I'm just saying he came over and then there's a small whiteboard on top of the whiteboard.
Okay, this is kind of a trick question, but this is f prime. Tell me what f looks like. This is the graph of f prime. What does the graph of f look like? And we're going from -6 to +6. What? I just dream up of ways to torture you.
Probably do. Probably have like a dream that looks like
Okay, why is this one weird?
it's always increasing. So it has like points of 0.
F F is increasing on the interval from -6 to +6 because f prime is greater than 0. Now, there are moments where f prime is actually equal to 0, but we can say that the function is constantly increasing on that interval. That's going to take a little bit of thinking. Also, f is never decreasing. Reason is f prime is never negative. So what does the function look like? Now take a close look at this graph and see if you can justify why it makes sense. This is the graph of f.
And it's always increasing, but then it still has when the derivative is 0, it still has the slope of 0.
Okay, slope of 0, slope of 0, right? And that's to match up with this one and to match up with this one. But since it's always positive, it increases in between the places where the derivative is 0. And you might ask, well, how much does it increase as it goes from here to here? As we go from this -3 to this +3-ish number, how much does it increase? Well, we go to the derivative and we say, how much is that area under that curve? The amount that's the area under that curve is exactly the amount of the function as it increases from this value up to this value. As we go from this point up to this point, that x value is equal to the area under that curve. And you can also justify, look at this, are there any areas that are below the x-axis? And the answer is no. Therefore, the function is never decreasing. This is like the giant slide. Yeah.
When it's never decreasing, you have to tell
No.
why it's not.
It would probably be best to always justify. In this case, f is never decreasing because f prime is never less than 0. Okay. All right. Now, pull out this worksheet that I gave you because we did these together. Now pull out the worksheet, the side that looks like it's where it says draw f of x. All right, take a look at that first one. Try to do that first one. And I'm going to bring up the answer key to that one. This is going to be your assignment for tomorrow, by the way. But I want to take a look at the answers to the first one. Okay, we're going to notice the notation. The notation is big. So problem number 1. Intervals where f of x is increasing, you would say the interval from 0 to infinity. There's a bracket on the 0. Infinity always gets a parentheses because we can't include it because it's not a number. And the question is, why is the function increasing? Well, look at the derivative. From 0 to infinity, the derivative, f prime of x, is greater than 0. This whole thing is using f prime to gather information about f. Look at the second one. It's decreasing from negative infinity up to 0. 0 gets a bracket, negative infinity gets a parentheses. Reason? Because f prime is less than 0. Now, these last two questions are new. The last one we can answer, x values where minimums occur. Well, a minimum of a graph is a place where the function goes from decreasing to increasing. And by observing what we said here, the function is decreasing and then it's increasing. Therefore, that's where a minimum has to occur at x equals 0. What would be the justification for a maximum? F prime changes from positive to negative. Okay, you don't. I gave you the assignment guide, but we're not going to start that until tomorrow. But I want you to finish that worksheet, just the front side, for tomorrow. And we have problem set due tomorrow too, by the way. FYI. You don't have. You can. Yeah, go ahead and try to sketch it, but you don't have to.